This is Josh White with JW Math Tutoring. Today's video is going to cover Digital SAT, Bluebook, Practice Test 5, Math Section, Module 2B, the harder of the two second modules on this test. So let's go ahead and get started.
But life is a dream the calculus could never predict.
Just before being working on Practice Test 5, Bluebook app, Digital SAT Math, Module 2B, the harder of the 2 second modules. Just want to point out a couple things. Of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And also, because I like to show as many methods as possible to solve some problems, this video will most likely go longer than the time allotted for this module. So just keep that in mind. Okay, first question here. We just have basic, Pythagorean theorem. A squared plus b squared equals c squared. So we're given the two legs, a and b, as 9 and 11. So we're just going to plug those in to, Pythagorean theorem and then use that to find the hypotenuse, which will be c. So we've got 9 squared plus 11 squared equals c squared. So we got 81 plus 121. So c squared is just going to equal 202. Then we can square root that to solve for c. So correct answer for this one is just going to be letter B. Next. Here we have a problem where we have 2 points. They just want to know what the equation of it is. So you could go ahead and you could find the slope just using the formula, y2 minus y1 over x2 minus x1. And if you do that, notice you're going to get 4 over 2, which is just 2. There's only one line that has a slope of positive 2, so that has to be our answer. By process of elimination, what do you need to find the y-intercept or anything else? We know that the correct answer is going to be B. Now, I will also just show you quickly how we can do this in Desmos. So all we would do is just go ahead, make a table, put in the 2 points that you're given. And then we just do a linear regression. That's going to give us the slope and the y-intercept, even though, like I said, once you know the slope, we know what the answer is. So 2 and 7, that just confirms B is the correct answer. All right, next up we have a question that deals with basically like margin of error for essentially like a study. And in this problem, 12% of the socks that they estimate are defective, and they tell you the margin of error is 3.62%. So what's the conclusion based on this information? So the main takeaway, the key concept or idea to know on this is that if you take the mean or the average, essentially you add the margin of error to it to increase that value. And then on the other side, if you subtract the margin of error, like that gives you the range that you expect the true mean to be between. So in other words, we take the 12%, we add the 3.62%, that's 15.62%, and then you also subtract 3.62% from it. That comes out to 8.38%. So the conclusion that you draw here is just that it is plausible, reasonable, that basically the true mean, the true average is that between 8.38% and 15.62% of the socks are defective. So correct answer is letter B. Now for question number 4 here, you have a truck which has this maximum weight capacity, and it's going to be hauling equipment in it, including some different size crates. So a couple things. First of all, you have to be careful when you're reading this because the truck has this maximum weight capacity, and it's going to haul this 190-pound piece of equipment. And in addition to that, there are the 2 types of crates. That's where like the X and Y come in. So you have to take the 5630 initially and you have to subtract 190 from it. And then what you're left with, the 5440, that is the the weight limit for the small crates and the large crates. The 25-pound crates, 62-pound crates. Okay, so right off the bat, C and D are wrong because they have the original weight amount as the limit, whereas uh, we want the 5440 because it tells us here to write inequality that represents the combinations of the 25-pound and 62-pound crates. It doesn't say anything about the 190-pound equipment, so we already have to remove that. So that's why you have 5440 on the right. Now, notice that on the left side, that part's the same. So really all you're determining here is, do I want it to be less than or equal to or greater than or equal to? Well, 5440 is the maximum weight. So therefore you need to be less than or equal to that number. So correct answer for this is just going to be A. Next up, number 5, we have a system of equations. We can do this multiple ways. If you want to solve this by hand, let's see here. How did I do this? I think I solved for y in the bottom one, and I got 5x over 2 equal to y. Plug that in to the first equation. Okay, then I went ahead and I multiplied everything by 2 just to get rid of the fractions. So just, multiply by 2 on both sides. And I got 5x equal to, let's see here. No, it's not 5x. Sorry, this is an x right here. So it's not 5x. It's going to be negative 13x equal to 26. X equals negative 2. Notice there's only one answer with negative 2. We do not need to spend the time and the effort finding the value of y. We know that the correct answer is letter C. Now, we could also do this very quickly in Desmos, probably much quicker than solving it out by hand. So I'm just going to type in both equations. There's the first one. Here's the second one. Where do they intersect? Right here, negative 2, negative 5. Correct answer confirms it's letter C. Now we can move on to the next question. All right, here we have a question where they just asked the range of these scores. So we're just going to subtract highest value minus lowest value. 52 minus 23. Correct answer is 29. That's it. Nothing more to do. We can move on to the next problem. All right, now question number 7 here. This is basically a word problem where you set up a system of linear equations and solve it out. So I'll show you how to set it up, but for the actual solving, I'll talk about 2 different ways you could do it. I won't actually bother doing the work by hand, just because we do have the Desmos calculator. So basically, I'm going to use X for loaves of bread and Y for eggs. So the first customer bought 1 loaf of bread, so 1x, and then plus 2 dozen eggs, and that total was $12.45. Second person paid $19.42. 4 loaves of bread, 4x, but only 1 dozen eggs, so just plus y. So this is what the system of equations looks like. Now, what we could do is, the quickest, easiest way is to just go ahead and go to Desmos and put in the 2 equations, see where they intersect, and get our answer. All right, so there's the first line. Here's the second line. Where's the intersection? 3.77, 4.34. So what do they want to know? They want to know the cost of 1 dozen eggs. So for me, eggs were the y variable, the second variable. So therefore, the correct answer for this is going to be 434. It's going to be letter D. So just so you know, an alternate way that you could do this as well is you could technically go ahead and back solve it. And so the way that would work is, and I guess I'll probably go I'll just go back to Desmos just to show this. I'm just going to demonstrate it with answer choice D since we know that one's correct. So you would start with the price of eggs, okay, 434. In answer choice D, with taking that, so we know that I'm going to take the top equation. We know that 1 loaf of bread plus 2 dozen eggs equals 12.45. Okay, so if I just plug in the price of eggs into the top equation for the first customer, notice it comes out here to 377. So that means eggs cost 377. So what I'm going to do now is take both those prices, 377 and 434, and plug them into the second equation and see if they add up to 1942. 4 times 377 plus 434. Since they do, that tells me it's the correct answer. If they did not, and I'll just do an example of like, answer choice A, for example. Let's say eggs cost 377. X plus 2 times the 377 for eggs equals 12.45. Okay, then that would mean that a loaf of bread is 491. Now I go to the second equation and I do 4 times 491 plus 377. Does that equal 1942? Excuse me, in the second equation. No, it does not. It's 2341. It's too high. So that tells me that this is wrong. This is incorrect. This is not not a valid answer. Again, it's honestly it's longer. It's more work than just being able to type both equations in Desmos and graph them out and look for intersection. But it is an alternate way you could get the answer. All right, next up, here we go. We have another system of linear equations. So you can technically do this one by hand, but it's so much quicker, it's so much easier to just go to Desmos and graph out both the equations and see how many times they intersect. So you have to zoom out to see them here. Okay, at how many points do these equations intersect? Well, the answer is 0, obviously. You can see that the horizontal line, y equals 18, is basically too high. The vertex for this parabola has a y value of 15, so therefore the 18 is going to be above that. They will never intersect. The correct answer for this is 0. Now, here we have another question where it's basically a system of linear equations. They want to know what's the greatest possible value of x. So again, you can do this one by hand. It's actually not that bad, so I'll just work it out first, and then I'll show you in Desmos. So since they're both in not slope-intercept form because it's a quadratic, but y equals form, you can just set them equal to each other. Okay, and then go ahead and solve. Moving the x and the 9 over, you get x squared plus 15x plus 54 is equal to 0. And then this can just factor as x plus 9, x plus 6, x equals -9 or -6. What is the greatest value of x? Well, -6 is greater than -9. So therefore, correct answer is going to be letter A. But notice, it doesn't even have -9 as a possible answer choice here. You know what I'm saying? Like -6 is the only one of the two solutions you listed, so by process of elimination, it has to be that. Again, we can go to Desmos. We can graph both of these equations out. All right, what are the two solutions? So here is one at -9, and here's the other at -6. So which one is greater? It is -6. Just confirms correct answer is letter A. All right, number 10 here, next problem. You are given a slope of a line and you're given its x-intercept. What is the y-intercept? So you can do this one by hand. Technically, the easy way to do it is to take just y equals mx plus b, plug in the slope, plug in the point, the x-intercept, and then just solve for b. So 0 equals now this. 3 goes into 6 2 times. The two negatives are going to cancel. It's going to be 10 plus b. b equals -10. Okay, so the correct answer for this is just going to be -10. But again, this problem can be solved in Desmos. Might probably is quicker, depending, how long it takes you to enter things on the calculator. So first, create a table, enter your 1 point. Next, linear regression, and you're going to enter your slope in. And then when it solves this, what is b? What is the y-intercept of this line? It's -10. There's your answer. It just confirms that that is correct. All right, next, number 11. So, a couple things. First, if you're going to do this by hand, notice if you multiply out both sides, i.e. distribute, you have different x values. That means that there is going to be a solution guaranteed, okay? And if you went ahead to solve it, you would technically get 15x equals 0, or just x equals 0. So how many solutions does this equation have? Well, it's just one. Technically, the number 0. However, you could also confirm this in Desmos. Now, there's one thing to be careful of. If you type it in like this, okay, you will see a vertical line here, and it is highlighted, and so that indicates that there is a solution. But the way that I like to do it, when you have a problem where it's possible that it's no solution or infinite solutions, those are answer choices here. It's not asking for the numerical value, but asking how many solutions. I technically like to type y equals the left side and y equals the right side, because that will show, if it is a true no solution, it'll show two parallel lines. If it is an infinite solution, it will show the same line on top of itself. So we can see here, okay, this is true. There is one solution to this equation, and it's right here. Again, x equals 0, what we found earlier. So yes, just confirms correct answer is letter A. All right, next we have a word problem, and they give you an equation for it, linear equation, with two variables, and this basically is just interpreting this linear equation, linear function, however you want to think of it, and they want to know what the 6 stands for. So the correct answer, I would just tell you, it's going to be letter D, and the reason is because if you notice here, Y is the total amount of fabric purchased, okay? So like Y is total, it's kind of like total fabric, to start with, or at the start or at the beginning, however you want to think of it. Okay. Then for each suit, she uses 5 yards and she made X number of suits. So the 5X, this is the total fabric used for X number of suits. So however many suits she makes, multiply that by 5, that's the total amount of fabric that she uses. So when you subtract those, in other words, I have this much amount of fabric to start, I use this much amount of fabric to make suits, and when you subtract the difference, if this difference here is +6, that's how much is left over. That's how many yards of fabric there are that haven't been used to make suits. So correct answer for this is just going to be letter D. All right, 13. This one again, there's multiple ways you could do this. You could do this in Desmos. Honestly, it's probably going to be quicker that way, but I'll just briefly review the concept and then we'll get to it. Essentially, to figure out for no solutions for a quadratic equation, we're looking for the discriminant to be less than 0. So, I mean, some of these you can factor and you can easily see that it will have a solution by factoring, but essentially, the correct answer is going to be letter D. Now, you can confirm that just by plugging in all these values here. So let's see, 5 squared is going to be 25. 4 times, put the wrong number here. This should be 5, not -14. 4 times A times C. That will simplify to 980. And I put the, all right, I mixed up the A's, sorry, the A's and the B's. So get rid of this. This is the -14. It's 196. So you get 196 minus 980. That is negative 784. That is, of course, less than 0. Therefore, it will have no real solutions. But again, much quicker, much easier way is just go to Desmos and go answer choice by answer choice. This is basically, I mean, it's kind of like a back solving. You're checking the answer choices. So no real solutions. Another way to think of that is that means no x-intercepts, because the x-intercepts are the solutions, are the roots, are the zeros, whatever you want to call them. So this has two solutions, answer choice A. All right, that's not it. Make this minus, make this plus. This has one real solution. That's not it. Now let's make this minus, and let's make the front 5. This has two real solutions, so this is not it. And now just to confirm answer choice D, notice no real solutions, no x-intercepts. Therefore, this confirms again D is the correct answer to this problem. All right, next up, question number 14. So here we have a question that deals with an exponential function. Okay, there's two ways to solve this. It's really kind of like, I guess, yeah, there are two ways. Let me put it this way. There are two ways to solve this. One way is just straight back solving using Desmos, and I will probably do that way first. And then after that, I'll show you how you could technically also use picking numbers. So you're given this general function. So let's go to Desmos. Okay, so here's the original function. And they say it can be rewritten as 1 plus p. Now my p these are my answer choices I'm plugging in. Okay. So, which of the following is closest to the value of p that if you plugged it into this other form of the function down here, it would be equivalent? So notice this first one is very, very, very close. It's not quite identical. I mean, it's pretty close over here on the left, but once you get past like about 15 or so, they start to separate a little bit. But it is still pretty, but it also says closest, so it might not be exact. So let's check the other answers and see, do they get any closer? So if I change this to 21, notice it gets further away. What about 46? Nope, even further away. Again, we're looking at the blue. The blue is the one that's changing. And now 96, no, even further away. So 16 is clearly the one that is closest to the original. So correct answer is going to be answer choice A. Now, what you could also do too is you could do a strategy of picking numbers. So what I mean by that is, let's get rid of the graphs here. Okay, what I'm going to do is this is going to actually be similar, but it's not quite the same thing, but it is still kind of similar, and then I'm going to run through the answer choices. I'm going to let x equal 4. Okay, so the original function, I'm going to call it the original function is 1.84 to the 4th. So you just do that out. Sorry, not to the 4th. Excuse me. I chose 4 because it becomes 1. It's 1.84 just to the 1st. Now, I'm going to go through my answer choices and I'm going to plug them in to 1 plus, the answer choice over 100 to the 4th. And I'm going to see which of those equals 1.84 or is closest to it, really. All right. So first answer choice, 1.81. It's pretty close. Again, it's not exact. We're going to see if we can find something closer or not. And then we go to B. 2.144. Okay, getting much further away. Now I would go to C. 4.54. Okay, getting further away. And lastly, D. I mean, obviously we know by this point this is not going to be the correct answer, but just to prove it to you. Okay, 14.757. Okay. So which of these is closest to the value I got evaluating the original function? Well, it's obviously A. 1.81 is closest to 1.84 compared to my other three choices. So that's just an alternate method you could use, basically using the strategy of picking numbers. All right, next up, here we have number 15. We have another system of linear equations. And the problem is they want this to be no solution, which means we want same slope, different y-intercepts. So normally you would go to Desmos and you would find the value, you could use a slider to find the value of p, but because it's a student-produced response, sometimes on these questions they make the answers fractions and you don't know, like, is it 0.212912 or is it 0.2913 or 0.2914? And it can be a lot of work to kind of like zoom in on the decimal to get it exactly parallel. So instead, I would probably go and look at the following strategy. So first thing I'm going to do is I'm just going to rearrange these equations slightly. So the top one, I'm just going to write to 7r minus pw, and I'm going to set that equal to -6. The bottom one, I am going to, again, bring everything else over onto the same side for the variables for the r and w, and then leave 11 over here. Okay, so now at this point, there's two ways you could do this. You can either notice that the multipliers, okay, when you have two equations, system of equations, and it's in standard form, the multipliers on x and y are the same number when it's no solution, but for the number on the right side, it's different. So what that means is here, 7r to 7r, the multiplier is just 1. So that means here, negative p times 1 has to equal -10. Or in other words, negative p equals -10, or p just has to equal 10. Like these, in other words, if these are the same numbers, these have to be the same numbers. And since they both have negatives, that just means p is positive 10. So that's one way to think of it. Alternate way to think of it is, when your lines are in standard form, the shortcut formula for the slope is -a over b. So for the top line, it's going to be -7 over -p. And that slope has to be the same as the slope for the bottom equation, which is going to be -7 because it's -a over -10. So again, matching these up, for these to be equal, well, the -7's already matched, so the negative signs already matched, so that tells you that p has to be 10. So that's just an alternate way to think about it. Again, you could go to Desmos and you could do the slider, but the problem is sometimes it's not a nice integer and it can take you a while to figure it out. All right, next question. Here is a parabola quadratic function. They want to know the value of b and c. So first, I'll just briefly show you the way you would do this by hand. I'm not going to go through all the work just because there's a much quicker, easier way to do it in Desmos. But to do this by hand, what you would do is you would first note that a equals 2, right here, a in front of the x squared. So I would rewrite this equation in vertex form. I'd put the a out front and then x minus, and notice here is the vertex. The vertex is at -1, -8. So vertex form, x minus h squared, x minus -1 squared becomes x plus 1 squared, and then minus k, or -8. So now what you would do is you would technically square this out, and it becomes x squared plus 2x plus 1. Then you have to distribute the 2x squared plus 4x plus 2 minus 8, and then combine your like terms. Okay, so what is b times c? 4 times -6 is just -24. However, here's an alternate way you could do this in Desmos, which will be much, much easier. So just going to do a quadratic regression. I'm going to enter in the 3 points that were given here on the graph. So we've got -2, -6. We already saw -1, -8. And we've also got 0, -6. Now, quadratic regression, and I'm going to do it in standard form. Now you can either just look at B and C right there, or you can just multiply them in the next line and see that it gives you negative 24. So honestly, this way is so much quicker, so much easier than doing the math out by hand. But either way, correct answer is negative 24. Next up, we have problem number 17. Here we have a line. So to tell us that this is the graph of the line translated up 19 units, and they want to know what the equation is for the line itself. So first, here's the theoretical way behind this. So notice the y-intercept is here at 0, 3. So that is shifted up 19 units. So if you shift that down 19 units, it's going to go to 0, negative 16. Also, this line has a negative slope. Therefore, the slope of the line will overall have to be negative. The y-intercept will also have to be negative. So therefore, the equation is going to look something, just hypothetically, this is not correct, but just say like negative 3x minus 16, like something like that. So if C and D are positive values, like if you just fill in numbers for those, which of these forms matches what I have here? A negative something x minus, a number after it. So the correct answer, notice it's going to be A, even though they put the x term second and the y-intercept term first. Like, notice that's the one that matches. And you could like plug in the numbers here just to, confirm that. However, an alternate way that you could do this is you could get the actual equation of the line, and I'll just show you quickly, how we can do that. And then it'll be a little easier, like to see that, to see it as well. All right, so if we go to Desmos, okay, so we create a table. Notice we've got a point here, 0, 3 already. That's the y-intercept. And there's also a nice point, it looks like, right here as well. Negative 1, 7. All right, so this is the equation of our given line. So I'm just going to define that as f of x. Okay, get rid of this. So now all I need to do is basically take that and shift it down 19 units. So I'll do a vertical translation down 19 units. So here's my new line. Okay, so first of all, it's obviously going to have the same slope, and we can see here from the graph, so its y-intercept is negative 16. So the equation of this new line, this basically just determines it. It's, you could say whatever, f of x equals negative 4x minus 16. Or if you want to switch it, because they have the y-intercept first, negative 16 minus 4x. So now, basically, like D is positive 16, C is positive 4, and then, but they have, the minus in front. That's why it has to be letter A. So that's just kind of like an alternate way that you could think about or solve the problem. Next up, we have a problem dealing with similar triangles. So essentially here, we know that this is root 34 just from A to B. We know AC is 3. We know CE is 21. Note, this makes this whole thing 24. And they want to know the area of ADE. So easiest way to find area of ADE is just, use 1/2 base times height. And we're going to use AE as our base, and we're going to use DE as our height. So we have to find what DE is equal to. Easiest way to do that is to first do Pythagorean theorem on the small triangle to find BC. So in other words, 3 squared plus BC squared is going to equal root 34 squared. Or in other words, 9 plus BC squared equals 34. BC squared is 25. BC is just 5. Square root both sides. So this is 5. Now, from here, there's technically 2 ways you could do it. The area, the easiest way, what I think is the most straightforward way, is to notice the scale factor between the small triangle, this right here, and the large triangle is basically 3 to 24, or in other words, it's 1 to 8, i.e., to get from BC to DE, you have to multiply by 8. Because from here, small triangle is 3, large triangle 24 times 8. So this side will be 40. So the area is going to be 1/2 times 24 times 40. That just comes out to 480. And that's going to be your correct answer. Now, technically, an alternate way to do this, I don't think this is necessarily any easier, but this, just the way some students may look at it, you can technically find the area of the small triangle, which would be 1/2 times 5 times 3. Basically it's like 7.5. Then, to go from the area of small to area of large, you multiply by the scale factor, but you have to square it because area is two-dimensional. So you multiply by 8 squared or by 64, and you'll see that you get the same exact answer of 480 if you want to do it that way. All right, now this problem is a little tricky to read, but in terms of actual solving it, it is not a lot of work at all. You can actually do the entire thing in Desmos too. So first, here's how you would solve this just kind of by hand by setting it up. So be careful. Your result of increasing the quantity x by 400% is 60. So notice you're starting with x and you're increasing it by 400% of x. So 400% as a decimal is technically 4, and then of is multiplication x. So really, this translated to an equation, it just becomes x plus 4x equals 60. So you just get 5x equals 60, x equals 12. Correct answer is going to be letter A. Now, here's a second way you could solve this, basically with back solving. You could start with the answer choices, and I'll actually just go do it in Desmos. You start with the answer choices, take 400% of that. So start with 12, essentially multiply it by 4 to take 400%. Now you have to add it to the original because you're increasing it and see, do I get 60? And the answer is yes, I do, so that's the correct answer. Everything else, if you multiply it by 4 and then add it, you do not get 60 as your result. Okay, so you could back solve this one as well, or you could also, just to show you, just do it this way. X increased by 400% of x is 60. I just literally took the words and made it into an equation just with the percentage, even in there. And notice it gives me the answer right here of 12. X equals 12, it graphs this vertical line. That's the solution. So this is just a way you can honestly do this question in Desmos in 5 seconds and get the answer. Next up, we have question number 20. This problem deals with some geometry, specifically Pythagorean theorem, right triangles. So it looks like a difficult question, but it actually is not that bad to solve it out. All right, first I'm just going to try to draw a rough sketch of what's going on here. So, okay, we have a circle. Just ignore, the poor drawing. Its center is at H, comma, K. All right, then they tell us about 2 points, okay? Point A and point B. They both lie on the circle. Okay, they give us some coordinates for point A. So point A has coordinates of h plus 1, comma, k plus root 102. What that means is A is 1 unit to the right of where the center of the circle is. So if I just go 1 unit to the right, and then also I go up by square root of 102 units, this will get me at point A up here, okay? Now, where we use that is basically for drawing a right triangle. So for example, if I go 1 unit to the right, and then I go up the square root of 102 units, notice now I can make a right triangle. And the hypotenuse in this right triangle is this line segment here. I'm just going to call this C, which is also a radius of the circle. Now, point B is going to also be somewhere on the circle. And we know that since it tells us A, okay, actually I should not call it C because this is the center, technically point C. So let me just instead call this R, radius. All right, so point B is going to be down here approximately, such that angle ACB, when I draw this, this also makes a right triangle. Okay, again, ignore the poor drawing, the fact that it doesn't look like a right triangle, just pretend that it is. Okay, so they want to know the length of AB. So in other words, I would connect, here. They want to know this line segment right here. This is what we're figuring out as the answer to the problem. Okay, so all we're going to do is first do Pythagorean theorem with the small triangle. Okay, the one that has a leg of 1, a leg of root 102, and then the hypotenuse being r. So just 1 squared plus root 102 squared equals r squared. 1 plus 102 equals r squared. R squared is 103, and now we can just square root both sides. So r, or the radius of the circle, is root 103. So let me just erase this. So this side right here, root 103. This side from B to C, also root 103. Now, to find the line segment AB, i.e. the hypotenuse of this right triangle, there's two ways you could do it. First, we could do Pythagorean theorem. So I'll show that method. And then second, I'll talk about a shorter way that you could actually do it. So it's going to be root 103 squared plus root 103 squared equals, again, I called this x, so we'll just call it x squared. So root 103 squared, that's just 103. Root 103 squared, that's just 103. That's equal to x squared. So we get 206 equals x squared. Now we can square root both sides. X is just going to be square root of 206. So the correct answer for this problem is letter A, because that doesn't simplify. 106 is just 2 times 103. So now there's one spot in this where you could take a shortcut and save a little bit of time, a little bit of work. Okay, in the triangle, let me just see if I can change the color here. So in the large triangle, okay, right here, triangle ACB. Notice the two legs are congruent to each other. They're both root 103 because they are both radii in the circle. What that means is this is technically a 45, 45, 90 triangle. 45, 45, okay, and then we got the right angle here of 90. So what that tells us is we know in a 45, 45, 90 triangle, the hypotenuse is just equal to square root 2 times the legs. So if you notice that, you could just do root 103, which is the leg, multiply it by root 2 to get the hypotenuse, and this is just equal to square root 206. So that's just a shortcut you could use to save a little bit of work and a little bit of time if you recognize that triangle ACB is a 45, 45, 90, basically isosceles right triangle. All right, next up we have number 21. This one deals with flux. If you read through this, gigantic paragraph here, it seems like a complicated problem, but it actually is not that difficult to solve. I will also show you at the end just a very shortcut method you could use to solve this all in just entirely one step. So if you draw a picture out, basically what you have is like one small square. Okay, say the sides are like x and x. Then next to it, you have, the larger square. Okay, and they tell us that the side lengths are 3 times, for the larger one, 3 times the small. So this would be like, say, 3x, and this would be 3x. Now, again, if you read through all this, wall of text here, basically you get the equation that flux is equal to field strength times area. So they give us the total flux for these two squares together. Okay, that's the 4640. Field strength is 29. That's given right here. Electric field with strength 29 volts per meter. Okay, now the area, here's where you're going to come up with an expression for x. by just, this is going to be x squared for the area. This is going to be 9x squared. So together, the total area is just 10x squared. So now, go ahead, you multiply this out, 4640 equals 290x squared. You divide by 290. You are going to get x squared equals 16. X is going to equal 4. Now, they want to know what is the flux through the larger square. So now we go back to the equation and we do the field strength, which is 29, times the area of the larger square. So that's 9 times x squared, but now for x we can put in the 4 that it's equal to, which is basically just going to turn into 16. So now if you do 4 squared is 16, 16 times 9 is just 144. 29 times 144 is going to come out to 4,176, which is the correct answer for this problem. Now, here is the shortcut way, the way that you could figure out this problem basically entirely in one step. So, let me just clear the screen here so I've placed it right. We know that the total flux for both things together, okay? Remember the areas were x squared and 9x squared. X, 3x, 3x. Okay, we know the total flux is 4640. And we know that it's equal to field strength times the area. So what you notice is here, the total area is 10x squared. However, the area of the large, the square right here, is 9x squared. So that means the area of the large as a percentage of the area of both, or the total area, is just 9 over 10, 9/10, 90%. So therefore, the flux, which goes through this larger square, is just 9/10 or 90% of the total. So you just multiply 9/10 times 4640 and you get 4176 and get the same answer. So that's how you could figure this thing out, because again, it's just proportional, to the area. So of your total flux, 4640, 90% of it will go through this large square and 10% of it would go through this small square. So 9/10, 90% of 4640, 4176, that's how you could figure it out basically in just, one step. All right, the last question here, number 22 on practice test 5, module 2B. You are given a graph of a line here. I mean, technically a scatter plot, it's a bunch of random points, but we can see a line of best fit going through them. And they tell you that they make a new set of data by multiplying the y-coordinate of each data point that already exists here by 3.9. Which of the following could be a line of best fit for this new data set? Okay, so there's multiple ways that you could do this. What I would say is the easiest way is to pick a point here. So we have 215. And then I look for another point that is right, like kind of right on the intersection thing. So I know it's exactly on two values. So notice I have this point right here. Okay, 1840. So now, all I'm going to do is I'm going to multiply these two y coordinates by 3.9. Okay, and that's going to give me my two new values. So for the first one, and let me just go to Desmos just to do this, it's going to be 58.5. So my new point is 58.5. And for my second one, it's just going to be 156. So it's going to be the point 18, comma 156. So now all I have to do is go to Desmos, plug these 2 points in, and it's going to give me their slope, and it's going to give me their intercept, and I have the answer right there. I mean, we can do it by hand, but since we already have Desmos up, I'm not going to bother just subtracting the numbers by hand and finding the slope and everything. So create a table. Then we're just going to do a linear regression. All right, so there are my 2 points. Okay, here's my linear regression. What is my slope and what is my y-intercept? So my slope is right around 6, and my y-intercept is around 46.3. So looking down at these answer choices, okay, C and D are clearly out. They both have y-intercepts of around 12. That's nowhere near 46. So get rid of it. And now when it comes to these two, well, only one of them has a slope which is close to 6 to the number I got. So get rid of this. Correct answer for this one is going to be letter A right here. Now, what you could also do is you could go ahead, just to kind of like briefly discuss this as well. You could technically find the slope of this line right here, and then you could write that equation out, whatever it happens to be, y equals, blah, blah, x plus whatever. I think it's y equals 25 over 16x plus 11.875, roughly, if you work it out. Okay, then then with that equation, what you do is you put, basically you multiply the entire right side, which is what the y value is, by 3.9. So in other words, you multiply the slope by 3.9 and you multiply the y-intercept value by 3.9. And that will come out to something which is very similar to what I just found in Desmos. However, I think it's much easier to do it the way, like the first method that I did, which is just take 2 points, multiply the y coordinates by 3.9, and then go to Desmos, find the slope, find the y-intercept, figure out what the answer is. I think it's much, much quicker, much easier to do it using that method than the second method I described. All right, so that was practice test 5, module 2B, the harder of the two second modules in the math section for this digital SAT Bluebook practice test. If you have any questions or comments about this test, please do leave them below. Otherwise, please give this video a thumbs up if you like it, subscribe to my channel, sign up for notifications as well, and of course, watch the videos that cover Module 1 for the same test and also Module 2A from this Practice Test 5 as well.